The Marquis of Worcester, the forgotten pioneer of the steam engine. Nestled in the heart of Monmouthshire, the stoic ruins of Raglan Castle stand as silent sentinels of a bygone era. These ancient walls, bearing the scars of time and conflict, guard a story seldom told, a narrative that intertwines nobility, innovation, and the embryonic stages of a technological revolution. Who was Edward Somerset, the second Marquis of Worcester, and how did his endeavors within these very stones ignite the first sparks of the steam age? Today, we journey through history to uncover the profound legacy of a man whose contributions laid the foundation for the machinery that propelled the Industrial Revolution. Raglan Castle. Constructed primarily between 1435 and 1525, Raglan Castle epitomizes the transition from medieval fortress to Renaissance palace. Once the seat of the powerful Herbert and Somerset families, it reflects a fusion of military might and refined taste. The castle's proximity to rich coal deposits and iron ore in Monmouthshire positioned it at the nexus of early industrial activity in England. Notably, the tower bears physical evidence, marks and structural adaptations that attest to the experimental work of Edward Somerset, who in the 17th century installed a steam-operated device within these walls. These modifications, though weathered, represent some of the earliest interactions between built heritage and industrial technology. The Marquis of Worcester and his family legacy. Born in 1601, Edward Somerset was heir to one of England's most esteemed noble families, with titles dating back to the creation of the Earldom of Worcester in 1514. His father, Henry Somerset, the first Marquis of Worcester, was a staunch royalist during the English Civil War. In 1646, at 85 years old, he defended Raglan Castle against parliamentary forces for nearly 2 months, a testament to his unwavering loyalty and tenacity. Edward inherited not only the title, but also a profound intellectual curiosity and a penchant for mechanical innovation. Educated and well-versed in the scientific discourses of his time, he was a polymath who sought to apply theoretical knowledge to practical challenges. Early knowledge and experiments with steam. The utilization of steam dates back over 2 millennia. Hero of Alexandria, an engineer and mathematician of the 1st century BCE, documented several steam-powered devices in his work Pneumatica. The aeolipile, often considered the first steam engine, consisted of a spherical vessel mounted on an axis, with bent tubes emitting steam jets that induced rotation. Despite its ingenuity, Hero's inventions were regarded as curiosities without substantial practical application. The lack of materials capable of withstanding high pressures and the absence of a theoretical framework for thermodynamics limited further development. Throughout the subsequent centuries, steam remained a topic of interest primarily within academic circles, without transitioning into industrial use. The Marquis' innovations and experiments. In the early 17th century, the challenges of mine drainage were significant. Water ingress impeded coal extraction, with some mines employing up to 500 horsepower in the form of horse gins to operate drainage pumps. Edward Somerset recognized the inefficiencies and sought a mechanical solution. His water-commanding engine was a pioneering attempt to harness steam for practical work. The engine comprised 2 large sealed vessels filled alternately with steam from a boiler. As steam condensed, it created a vacuum, and atmospheric pressure forced water up from the mine into the vessel. By cycling between the 2 vessels, a continuous pumping action was achieved. In his publication, A Century of the Names and Scantlings of Inventions, the Marquis described an experiment. I have taken a piece of a whole cannon, whereof the end was burst, and filled it with water 3/4 full, stopping and screwing up the broken end, as also the touch hole, and making a constant fire under it. Within 24 hours, it burst and made a great crack. This observation highlighted the expansive force of steam, a fundamental property critical to steam engine operation. Although detailed technical specifications are scarce, contemporary accounts indicate his engine's capability of raising water to considerable heights. Reports suggest that it operated at a rate of 40 gallons per minute, a remarkable achievement for the period. The Marquis's work predates that of Thomas Savery, who is often credited with the first practical steam pump by several decades. Challenges faced by the Marquis. The 17th century was a tumultuous era in England, characterized by civil war, political upheaval, and religious conflict. As a Catholic and a royalist, the Marquis found himself on the losing side of the war. The parliamentarian victory led to the confiscation and sequestration of royalist estates, including his own. Financial hardship ensued as he expended his diminishing resources on his inventions. Moreover, the intellectual climate was not conducive to radical technological advancements. Skepticism and superstition were prevalent, and the lack of an established patent system made it difficult to protect and commercialize inventions. Despite these obstacles, the Marquis endeavored to promote his engine. He petitioned King Charles II for support and sought to form a consortium to fund the widespread deployment of his technology. Unfortunately, his efforts were met with apathy and ridicule. Contemporary society viewed his claims with incredulity, seeing them as the eccentric pursuits of a destitute nobleman. After his death in 1607, his wife, Margaret O'Brien, continued to advocate for his work, but without significant success. The road to steam engine advancement. While the Marquis of Worcester's contributions were largely unacknowledged during his lifetime, they planted seeds that would eventually bear fruit. In 1698, Thomas Savery patented a new invention for raising of water and occasioning motion to all sorts of millwork by the impellent force of fire. Savery's design shared similarities with the Marquis's engine, notably the use of steam to create a vacuum for pumping water. However, Savery's engine was limited by its inability to lift water more than approximately 20 meters due to the pressure constraints of available materials. Building upon these concepts, Thomas Newcomen, in collaboration with John Calley, developed the atmospheric steam engine in 1712. Newcomen's engine introduced a piston and cylinder mechanism, using atmospheric pressure to drive the piston down after steam condensation created a vacuum. This design significantly improved efficiency and reliability, making it suitable for widespread use in mine drainage. These incremental advancements illustrate the iterative nature of technological progress. Each inventor built upon the discoveries of predecessors, refining concepts and overcoming material and engineering challenges. The cumulative knowledge eventually set the stage for a transformative leap forward. James Watt and the transformation of steam power. James Watt, a Scottish engineer and inventor, catalyzed the evolution of the steam engine into a powerful and efficient machine. In 1763, while repairing a model of a Newcomen engine at the University of Glasgow, Watt observed its significant thermal inefficiencies. He noted that the repeated heating and cooling of the cylinder resulted in excessive energy consumption, as the latent heat of vaporization was wasted during each cycle. In 1765, Watt conceived the idea of a separate condenser, a chamber where steam could be condensed without cooling the main cylinder. This innovation maintained the cylinder at a constant high temperature, dramatically improving efficiency. Tests demonstrated that Watt's engine could reduce coal consumption by nearly 75% compared to the Newcomen engine. Watt further introduced the concept of steam expansion and double-acting cylinders, enabling the engine to produce rotary motion suitable for driving machinery across various industries. By the 1780s, partnering with industrialist Matthew Boulton, Watt's engines powered textile mills, breweries, and ironworks, playing a pivotal role in the Industrial Revolution. It is essential to recognize that Watt's breakthroughs were underpinned by the foundational work of earlier inventors like the Marquis of Worcester. The progression from rudimentary steam-powered devices to sophisticated engines was a cumulative endeavor, reflecting decades of experimentation, observation, and incremental improvement. The story of Edward Somerset, the second Marquis of Worcester, is a testament to the unheralded pioneers whose visions transcended the technological limitations of their time. Though overshadowed by successors, his endeavors at Raglan Castle represent a critical chapter in the history of engineering. His water-commanding engine embodied principles that would become cornerstones of steam technology, a force that propelled humanity into an era of unprecedented industrial growth. Recognizing the Marquis's contributions enriches our understanding of the steam engine's evolution. It underscores the importance of perseverance, intellectual curiosity, and the willingness to challenge conventional wisdom. As we reflect on the monumental impacts of the Industrial Revolution, it is fitting to honor those like the Marquis of Worcester, whose early explorations made such transformations possible. From the weathered stones of Raglan Castle emerged the initial murmurs of a revolution, whispers that carried forward, amplifying through the efforts of inventors and engineers, ultimately reshaping the fabric of society and powering the modern world.